this problem from polar equation, and the problem is find the polar equation of straight line joining 2 points on the circle. This is given by r, this is equal to 2d cos theta. Clearly this is a circle. We write or we draw a rough sketch of the circle, and the pole on the circumference of the circle, and the initial line as the diameter. This is the initial line and this is the pole. Let at any point P, this is r theta on the circle, so this is r and this is given by theta, and this is the center of the circle and this is the diameter d. Sorry, this is the radius, so OA is the diameter, this is 2d, and if we add PA, then clearly this is right angle. Okay, so from the triangle or right angle triangle, we can write this r by 2d, because this is d, this is equal to cos theta. So we get r, this is equal to 2d cos theta, and this relation is given. Okay, and with theta 1 and theta 2 at their vectorial angle, also find the equation of tangent to the circle at that point. So we have to find the equation of straight line with 2 points or joining 2 points on the circle. Let one point be A1 and other point be A2. Here the vectorial angle theta, this is equal to theta 1, and here theta equal to theta 2. We have to find this straight line. Okay, and since A1 and theta A2 are 2 points on this circle, so if we take coordinate of A1 as r1 theta 1 and A2 as r2 theta 2, then these 2 points lies on the circle as well as the straight line. Okay, and we first let equation of straight line. Equation of straight line is L by R, this is equal to, or we say here not L, 1 by R, this is equal to A cos theta plus B sin theta. This is 1. And here the circle is R, this is equal to 2D cos theta, this is named as 2. Let A r1 theta 1 and A2, this is A1, A2, r2 theta 2 lies on 2 and on 1. Okay, this 2 point lies on 2, this is lies on circle, and that is lies on straight line. So this point satisfy 1 and 2 together, and from 1 we get 1 by r1, this is equal to A cos theta 1 plus B cos, sorry, this is also theta 1, and from 2 we get, we write this is, and r1, this is equal to 2D cos theta 1. Now putting the value of r1, that is 2d cos theta 1 here, we get the result 1 by 2d cos theta 1. This is given by A cos theta 1 plus B sin theta 1. This is not cos theta 1, this is sin theta 1. Okay, now 1 by D, this is given by A into 2 cos square theta 1 plus B into 2 sin theta 1 cos theta 1, and this relation gives 1 by D, this is equal to A into 1 plus cos 2 theta 1 plus B into sin 2 theta 1, and this is relation number 3. And similarly, by putting this point in 1 and 2, we get the same type of result, and we directly write the result is 1 by d. This is equal to a 1 plus cos 2 theta 2 plus b sin 2 theta 2. This is relation number 4. Now to find the value of a and b, which are two arbitrary constant of straight line, from 3 and 4, we make the operation as 3 into sin 2 theta minus 4 into sin 2 theta, then b already cancel out, and from this and this relation we get the value of a. We directly here the value of a is this 1 by 2d into 1 minus tan theta 1 tan theta 2. Similarly, we make the same type of operation and getting the value of b. This is 1 by 2d into tan theta 1 plus tan theta 2. These two values are done by 2 or 3 line calculation. Okay. Now we put the value of a and b in relation number 1 to get the equation of straight line, and the equation of straight line is given by 1 by r. This is equal to putting the value of a and b and taking common 2d directly, and this is 1 minus tan theta 1 tan theta 2 into cos theta plus b is tan theta 1 plus tan theta 2 into sin theta. Okay. To write it in symmetrical form, we write tan theta, all of tan theta are of the form sin theta by cos theta, and getting the result as 2d into sin theta 1, sorry, this is cos theta 1 and cos theta 2. This is equal to r into which is given by, from this relation we get cos of theta 1 plus theta 2, and this is cos theta plus, from here we get, this is given by sin of theta 1 plus theta 2 into sin theta. Okay, and clearly this relation can be written as more symmetrical form as 2d into cos theta 1 cos theta 2. This is equal to r into, this is also a formula of trigonometry, cos a cos b plus sin a sin b. This is given by r into cos of theta minus theta 1 minus theta 2. We let this is b and this is a. Cos a cos b plus sin a sin b. This is cos of a minus b. Okay, this is the equation of straight line a1 a2. This is the first required result. And now to get the tangent to the circle at the point theta 1, it is very easily done by putting theta 2, this is equal to theta 1. Why theta 2 is equal to theta 1? Then we get the tangent. Then this line becomes as this, because theta 1 and theta 2 are same. Then this point move towards the point of a1 and getting the tangent of the circle. And equation of tangent to the circle at theta equal to theta 1 we get by putting theta 2, this is equal to theta 1 in our relation. We get the relation, or we get the equation of tangent is r cos theta minus 2 theta 1 theta minus 2 theta 1. This is equal to 2d cos square theta 1. This is the equation of tangent, and also this is the equation of straight line. Okay, this is very important and interesting problem of polar equation. Thank you for watching.